When we're working with fractions, we can encounter a lot of different problems and processes. Here we have a division problem and also a simplification problem where we have a lot of variables with a lot of exponents. But if we break it down, we'll see that it's not that complicated. So first step, if we follow our order of operations, parentheses, no parentheses, E, exponents, M, multiplication, D, division. So we can do our division because everything else before that is done. But we're just going to flip the second fraction, right? When you divide, you just flip whatever's after the fraction sign. So let's do that. Rewrite it as a multiplication problem. 6x cubed y z squared over 2a b c times, and then we're just going to flip this fraction. So our top will be 3a to the power of 3 b c, and then our bottom will be 2xy to the power of 3 z to the power of 2. Okay, so we did our first part. Now we can just, since this is a multiplication, we can just multiply the top and multiply the bottom. Let's write it as 6x cubed y z squared times 3a cubed b times c. And then our bottom will be 2 times a b c times 2 x y cubed z squared. So now, what can we cancel? Well, let's just combine our like terms first. On the top and the bottom, we have, what's 6 times 3? 18. 18, and then x cubed. Y, any other y? No. So y times z squared times a to the power of 3 times b times c. A lot of variables here. Let's do our bottom. 2 times 2 is 4. 2, and then a times b times c times x times y to the power of 3 times z squared. So what can we cancel now? Well, we can cancel our 18 divided by 4. If we want to write that out, I'll just erase it and factor it out so we can cancel. 18 divided by 2 is 9. 9 divided by 3 is 3. And then 4 is 2 divided by 2. So we can cancel a 2 out of there. And then we can cancel an x, right? So we have x squared. And then for our y's, we can cancel a y out of here. And we'll have y squared in the bottom. And then we can cancel out a z squared. And then we can cancel out an a from the bottom. Right, a squared. And then we can cancel out a b. And we can cancel out a c. So what does that leave us with? It leaves us with 3 times 3 times x squared times a squared on the top. So 9 x squared a squared over 2 times y squared. So that is our solution for this example. In this example, there's a lot going on. We have a fraction and then the fraction with an exponent of 3 and a negative. So what we would do first is make sure that what's inside the parentheses is simplified as much as possible, right? Because the order of operations, PEMDAS, says that we do parentheses first inside the parentheses. But it looks like here were already factored as much as possible and simplified as much as possible. There's nothing that we could really cancel. So now we are going to deal with the exponent. What you could do is you could just multiply this and write it out as this times that times that. But an easier way to do this is just multiply the outside exponent times each individual factor. So I'll show you how we'll do that. We'll leave the negative outside still. So we have 3 times our outside exponent of 3 times a to the power of 3 times our outside exponent of 3. So that gives us 3 to the 9th. And then b times our outside exponent of 3. And then we have x plus y squared, also times our outside exponent of 3. Notice how we're doing every single factor times our outside exponent. And then we're doing the same thing to the bottom. So we have 4 times our exponent of 3, x to the power of 3, y to the power of 3 times our outside exponent to the power of 3, and then a squared minus b to the power of 3 times our outside power of 3. Notice how we didn't do what was inside this parentheses, because the parentheses overall is a factor. And so we just did the outside, or we just did the factor. But anyway, we did the exponent, so now we can just simplify all these new exponents and take away the parentheses and just leave the negative. So I'm going to rewrite this up here so I have more room. What we have, negative 3 to the power of 3 is 27. And then we have a to the power of 9, b to the power of 3, and then we have our x plus y to the power of 2 times 3 is 6. So that is our numerator. Now we have 4 to the power of 3. So 4 squared is 16, and then 16 times 4 again is 64. So 64, you can do that in your calculator if you want, but I just did it in my head, times x to the power of 3 times y to the power of 9 times this factor, a squared minus b times, to the power of 9. And then I'll just look at this real quick and see there is nothing else we can simplify here. So this is our solution for this example. Once again, we just followed the order of operations. We checked to see if we could do anything as far as simplification inside the parentheses. We could not, so we moved to exponents, right? PE exponents, and we did the exponents, and then once we did that, there was no further simplification we could do. Here we have another example, and it's actually very similar to our last example, and I'll show you why. But before I do, let me explain what this symbol is. It looks like a square root, but it has a 3. So it's called a cube root. And what that means, instead of multiplying left hand side times the exponent of 1/2, it is an exponent of 1/3. So square root, let's say square root of x is equal to x to the power of 1/2. But x, cube root of x, is equal to x to the power of 1/3. Okay? And so if you see a 4 over here, then you can write it as x to the power of 1/4, and so on. But that is what we're experiencing over here. Oh. So we can just rewrite this as 27 x to the power of 6, a to the power of 6 over 8, y to the power of 12, b to the power of 9, all that times the exponent of 1 over 3. Now, just like our last example, we take the outside exponent and multiply it by each factor. So if we do that, we have 27 times 1 over 3, and then x to the power of 6 times 1 over 3, a to the power of 6 times 1 over 3. Then we have our bottom. We have 8 to the power of 1 over 3 times y to the power of 12 times 1 over 3. Sorry, it does not look like a 12. And then b to the power of 9 times our outside exponent, 1 over 3. So we did the exponent. Let's continue simplifying. If we write, what is 27 to the power of 1, 3? Well, we can also write 27 as 3 to the power of 3. So 3 to the power of 3 times 1 over 3 is just equal to 3 to the 1, which is also equal to 3. So we can write it as 3, and then x, what's 6 times 1 over 3? It's 2. So same with a to the power of 2, and then 8 to the power of 1, 3 is 2. And I'll show you why here, because 8 can also be written as 2 to the power of 3, and we're multiplying by our outside exponent, right? So 3 times 1 over 3 is 1, so we have 2 to the 1, and that leaves us with 2. So let's move to our y. Our y here is 12 times 1 over 3 gives us 4, and then our b, what's 9 times 1 over 3 is 3. Now that we have this, is there any other simplification we can do? No. So that is our solution for this example. Here we have an example where we're trying to simplify, and we have to do a lot of factoring to get there. We have a difference of squares here, we have a trinomial, we have a common factor, and that'll probably leave us with a difference of squares. And then down here we have another common factor. But let's just start up here. Let's do the difference of squares. So we can write difference of squares as the square root of our first term plus the square root of our second term times the square root of our first term minus the square root of our second term. So that's factored. And then we can factor the bottom here. So what are two factors of 15? We have 15 and 1. We have 5 times 3. And that looks like it will leave us with 2, actually, if we have a negative 3 and a positive 5. Negative 3, positive 5 will multiply to negative 15 and add up to positive 2. So those are our factors for the bottom. We can write it as x plus 5 and x minus 3. Oh look, these will cancel, but let's just keep factoring for now. We have over here a common factor, x squared minus 9, right? That's the same thing. We just rewrote it, factoring out the common factor. And then we have another common factor in the bottom, which gives us x minus 5. Oh, and look, we can probably cancel those things. So when we're multiplying, we can just multiply the top by the top and the bottom by the bottom. So I'm just going to rewrite this as one fraction. And what can we cancel? Well, we can cancel this x plus 5. We can cancel the x minus 5. and we can cancel the x. So what we're left with is x squared minus 9 over x minus 3. Let me bring this up here. And if you'll notice, we still have a difference of squares that we can factor, right? Because we're able to take the square root of this and the square root of 9. So let's rewrite our top as the square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the second term, and then all that over our denominator of x minus 3. And what can we do? We can cancel, right? We can cancel that. And that leaves us with x plus 3, which we can't simplify any further. Now, I don't know about you, but I would rather have this than what we started out with.
Hey guys, if this video has been helpful to you, click the link in the description to get access to the complete Easy STEM Algebra 1 system, which includes a textbook, homework, and all of the course videos in order.